Hi, in this session, let us study what we mean by LCM. Now, as the name suggests, LCM means least or lowest common multiple. Now, how do you find out least common multiple or lowest common multiple of two numbers? But before that, let us first understand what do we mean by LCM. Suppose I have two numbers, say 12 and 9. Let me start with the most simple example. Now, what are multiples of 12? You know that multiples of 12 are all those numbers that appear in their multiplication table, right? 12 times 1, 12 times 2, 12 times 3. That is, the number multiplied by some other natural number will give you the multiple of this number. So, what are the multiples of 12? That is 12, 24, 36, 48, 60, 72, isn't it? 84, goes on. And what are the multiples of 9? 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, so on. This goes on, isn't it? Now, I want to know what are the common multiples for 12 and 9. Are there any common multiples for the first place? Yes. The common multiples are 36, right? And we also have 172. Maybe if I write furthermore, I can get some other multiples which are common among 12 and 9. Now, what is the least among this? Least common multiple among this is 36, isn't it? So this is what we call least common multiple or lowest common multiple. Now, to find out the least common multiple, is this the only procedure that we have? No, we have well defined mathematical procedures to find out what is LCM or least common multiple among the two numbers. Let us see how. Now, the first method in this case is I want to factorize 12 and 9 individually, that is separately. So, if I start factorizing 12, you know that 2 times 6 is 12, this is 2 times 3 is 6, 3 times 1 is 3. So, I can write 12 as 2 times 2 times 3. And how am I going to factorize 9? This is 3 times 3, 3 times 1. So 9 is 3 times 3, right? So now, how do you calculate LCM? LCM of these two numbers is a product of prime factors counted maximum number of times they occur. Isn't it? So LCM of 12 and 9 is the product of these two product of prime factors of these two numbers, and we are counting these prime factors maximum number of times they occur. 2 is a prime factor, 3 is a prime factor. 2 is occurring maximum 2 times in this number. So 2 times 2 is the first set. 3 is also a prime factor, but 3 is occurring once here, 3 is occurring twice here. So we are going to count the maximum number of times it is occurring. So this must be 3 times 3. Now what is left out is just to find the product of this. That is 2 times 2 is 4, 4 times 9 is 36. So LCM of 12 and 9 is 36, which is the same thing that you have got. And the second method here is to write 12 and 9 and side by side and factorize them using the prime factors simultaneously. Now let us see how we are going to factorize them simultaneously. 12 and 9 are the two numbers where 12 is an even number, 9 is an odd number. Let us see if we can find any such prime number which divides these two numbers. Is there any such prime number? Yes. 3. 3 times 4 is 12. 3 times 9 is, 3 times 3 is 9. That is 12 and 9 are multiples of 3 commonly. So let us start with this. 3 times 4 will give you 12. 3 times 3 will give you 9. Right? We'll start like this. Now if you see, 4 is an even number, 3 is an odd number, but there is no common factor which divides these two numbers exactly, right? So we will start by factorizing each thing individually. So let us start with 3 again. 3 does not divide 4 in any way, so let us keep 4 as it is, but 3 divides 3 exactly. 3 times 1 will give you 3, so we will write 1 here. Now we have 4, 1. If it is 1, you can just leave it there. But if it is 4, it is a non-prime number. So let us divide it with the prime number. The factor is 2. 2 times 2 will give you 4. And 1, keep it as it is. And 2 times 1 will give you 2, and 1 keep it as it is. So we proceed this with the same procedure until you get 1 and 1 here in the last set. Now what is left out here, what you have got here is, that is 3 times LCM of 12 and 9 is the product of these prime factors that you have got, that is 3 times 3 times 2 times 2, which is 36, which is the same thing. This is the same prime factorization that you have got here, which is the same number 36 again.